right? I'm going to give a demo, if that's okay. Otherwise, like, I'm a little bit more show than tell, right? So my name is Bob. I'm one of the co-founders of open source vector database company called Weaviate. I'm working with vector embeddings for a long time already. It's like I'm getting close to 10 years now. Somehow it makes me feel old when I say that, but it's true. And this was all before GPT and these kind of architectures. But the thing is that, you know, we saw this opportunity of like, hey, we can actually use these vector embeddings to do search. And because it's like, it's a type of, it's a data type. And what I'm going to do today is that I mean, there's just a lot of RAG, right? Don't you think? So let's talk about what's next, what's coming next. So I'm going to talk, I need to talk a little bit about RAG because I need to set the scene, but then I'm going to talk about what's next, right? So I have a couple of slides, and when I'm going to talk about what's next, I'm going to do a little bit of slides and a little bit of demo. And the demo is in Python because kind of everything related to AI is in Python. So that's, and if you're not familiar with reading code, it's Python. So you'll manage, right? Okay, just, yeah, some basic stuff, right? So why is this interesting? So this is interesting because, again, when I started with this, I can tell you one thing, nobody cared. The first time I ever did a meetup was just before COVID for Weaviate. That was in New York. And I was talking about vector embeddings. So I set up like, you know, Meetup like this. And, you know, I had pizzas like here and I had drinks like here. And exactly 0 people showed up. So that was like, because nobody cared. But then people started to care, and people started to care so much that these very serious companies like Gartner is such a serious company that they make us have the R in there, right? If we talk about them, so that's how serious they are. But they do the research, right? They put in the research and they research what's happening. And what's so interesting to see is that we've learned that this is not like a cool add-on anymore, right? People are using this and people are bringing this to production. We see that too as a company, right? So we're an infrastructure company, since we have a vector database. So we see that too. And these applications are going into production now. And so what we're doing is we're working on creating that stack, right, around Weaviate. And I just want to quickly touch on how we do that, because I need to explain that when I go in my demo and explain what's next. You need to understand that a little bit. So Weaviate is an open source vector database, right? So you can just use it. You can use Docker. You can spin it up. The demo I'm going to give, I'm do it embedded. You can just use it in any way, shape, or form. And nowadays, you know, you can. It's very common. You can do it serverless. That basically means you just tell us, I want a database, and it sets up everything for you. You know, have like an enterprise cloud version where you can do all the fancy stuff with, like, you know, with memory, CPUs, which is important because today, a vector database like Weaviate, it's not just a vector index anymore. It's like you can be very smart about like multi-tenancy features, blah, 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 et cetera, that kind of stuff, right? So it became very fancy. You have all these integrations with the models, what we just heard, the re-ranker models. We have then support things around that, and very important, related to what I'm going to do now, what we like to call education. Because you see, the thing is, this is so new, we need to help people, right, to understand, including ourselves, what's possible and how to build these kind of things. So this is Weaviate, this is what we do, right, as a company. And the thing is, so what we see now, so this is a nice 2x2. I love 2x2s. People on my team know that. I actually believe that the whole world can be captured in a 2x2. So this is one version of it, right? So we have a value and have time. And the majority of things that we see people do now, and what you've heard that people are talking about, that's vector-based search, right? That can also be hybrid search. So hybrid search is when you mix in like traditional filters, like BM25, that kind of stuff. But we group that together as vector search. And we get a lot of value from that, right? Because it's a different way than searching through vector search. But the cool thing was, what we also saw with the previous speaker, was out of that came RAG. RAG was like the use case where we said, like, hey, this is cool. This is like a unique use case for vector databases. Why? Right? Why a vector database? Because you do not know what the input is. Right? And if you vectorize the input, you can retrieve these candidates and send them into your into your model. And then we can also the naive RAG and that kind of stuff, and novel RAG. We can talk about all these kind of things, but as I promised you, I'm not going to talk about that. I'm going to talk about something new, and something new where we believe the most value is going to come from is something that we call generative feedback loops. So you might have thought about this, but if you have RAG is like a one-way street, right? You have query, you retrieve from the vector database. So vectorize, retrieve from the vector database. You throw these results into the model. And you can do that in a naive way. You can do that in like more novel ways and those kind of things. And you get an output. But the thing is, it's still a one-way street, right? From query to result. So the generative feedback loop, as suggested in the name, is that whatever you're generating, you store it back in the vector database with an embedding attached to it. And you can keep looping. And you can do a lot of cool things with this. So this is what you're looking at right now. It's a preview, right? So this is just a syntax of Weaviate in Python. And one thing that is different from any other database that you know is that when we add or update, in this case, a property, we give an instruction to the database. And in this specific case, we say, all descriptions should be in English, right? That's just the instruction we give to the database. So now if we store something, right, and we store a listing, in this case, I hope that the people that in Korean, I hope the translation is correct, but we basically give that description. So now if you query the object, the database knows, well, it's not in line with the instruction. So the output when you retrieve it is a beautiful apartment in the heart of Amsterdam. And we can give the database any instruction we want, right? So we can say, for example, adjust the description based on the availability of the neighboring apartments this week, right? You can give any instruction you want to the database. And the database starts to have an opinion on what's actually stored in the database. That's new, right? Because as the previous speaker said, like what we're so used to from these databases, like, you know, garbage in, garbage out. I believe that this is the first time that in the world of databases, combining them with these models, we're basically able to turn chicken shit into chicken salad, right? Isn't that great? So that is what we do with these feedback loops. And we publish a lot about that kind of stuff, right? This is really what we believe. This is really the new thing in database infrastructure that RAG, vector databases, are enabling. We call it an AI native database. So you can't just do still pure, scalable, etc. vector search with Weaviate. You can just do that. You can do hybrid search with it. You can do RAG with it. But you can also do this new stuff with it. And we see more and more developers actually going that next step where they say, like, how can we really, and that's where the name actually comes from, weave the models and the database together. So brings me to my demo. So a little bit bigger. So the demo, oh yeah, by the way, this demo, I gave this demo during Google Next a couple of weeks ago. So if you want to see it, it's online. It was for Google Next, so we're going to use Google's Gemini model for it. And it's an e-commerce data set, which has Google products in it, because it was during Google Next. So we want to do our friends from Google a favor, right? So you see where that's, so you understand where that's coming from. So just some practicalities, right? Okay, so the first thing that I'm going to do is we can use Weaviate many ways, shapes, and forms. We can use it in the cloud, we can use it in Docker container, or we can embed it in our notebook. So let's see if I need to restart it, or that's, oh yeah, I need to quickly restart the runtime, sorry. Demo. So here we go. So what you see now, it's basically, I don't know if people are familiar with that, but it's kind of a thing nowadays with databases that you embed it in the notebook. So as you see, there's like a process. So the database is not running in the cloud, database is not running locally, but it just runs inside the notebook. So, and as you can see, you can also do Docker, those kind of things, but we're not going to do that. So the first thing that I'm going to do is we have an e-commerce data set, so I'm going to create a collection. And basically what I'm saying here, so I'm going to say collections create. I'm going to create a product, a collection I'm going to call products. I set the vectorizer information for the Google model, so we're using Gecko. We're going to use a generative model as well, so I'm defining that as well. And then we have a handful of properties, right? So the title, the category, that kind of stuff. I'm also adding something, as you can see here, called personas. I'll get back to that, why I'm doing that. So we have a handful of products. So here you see them. This is just a JSON document, right? So you see here like a badge D and that kind of stuff, right? So what we can do, we can upload them into Weaviate. So basically what we're saying here is, get the products collection to a dynamic badge and add these objects with product ID, title, and what have you. So what we can now do is like we can retrieve that information, or there are 99 in there, and we can retrieve that information. And then you see, so Weaviate basically assigned, unique identifiers, and then you have the descriptions there, and so on and so forth. So let me pick one. Let's go for this one. The ID of the laptop bag. I need that for my demo. Here you see just all the, all the products. So far, nothing fancy. So let's see what's happened here. So if I now retrieve this document that I just mentioned, so you see here it's the Google laptop backpack, and then you see the vector embedding. Where does that vector embedding come from? Well, that was the one that I defined when creating the collection. So basically said, like, I want to use this model. Those are the integrations. You can use open source models, you can use your own models, you can use hosted models, whatever you want. You can bring the embeddings yourself. But in this case, we're using the Google model, right? So far, so good. The only thing we've done now is stored 100 products in the database, and we retrieve these products, and we've seen what the vector embedding is. So the first step is what you've seen is the vector search. So let's see what's happening here, right? So let me run it. So what's basically happening here is that we're saying like we have a client. At the client, we take the product. Here you see like damn it. So we have the products. We say products query, and then we have a function called neartext. The query that we have is travel mug. Because the database knows which model we're using, it can just vectorize that for us. We do not have to do that ourselves. And we tell it we wanted to return the properties title, description, and the link. The link is the image. And we say it just limited to 3 objects. And then we just iterate over it. And we show the output, right? So here you see, based on that query travel mug, it gets to these results, right? So this is pure vector search. This is it, right? And what you can see is that in the results, right? So it's like, it does not per se have a keyword match, right? So that's the power. That's why we use vector search, right? We don't always have a keyword match. There's also something that we can do is hybrid search. And hybrid search, that's kind of the fancy thing now in fact, it's purely when we look at search. So we do this exact same thing, but rather than a vector search, we do a hybrid search. So we take the query still is transformed into a vector embedding, but under the hood, we also do BM25, a traditional keyword matching. Matching. And the reason we do that is because if you search for something in a data set where the model wasn't trained on, you still want to be able to retrieve it. And it actually turns out that the combination of vector search with traditional keyword-based search, aka hybrid search, works best for that. Right? So the alpha, that's basically saying like how much do we use of one or the other, still 3. And now you see we get these kind of results back. So we're still talking about this first thing, still talking about vector search. Right, okay, then we have something fancy called AutoCut. So because you can calculate the distances, so you can basically, if there's a cut in the distance, right? So if the distance is bigger than other distances, the database kind of knows, well, it's now less relevant. So now I have the exact same query, but I'm just returning one result, the most relevant result, all done from the perspective of the database, right? But now it gets interesting, because now we added data to the database. See how simple that was. Just model, got the vector embeddings, did some very basic querying, vector-based search. Great, great, great. But now that new thing, what's that next step, right? What's that generative feedback loop? So I'm gonna hit this one. The only reason I'm hitting this one is because it has a API key in it that I don't want you guys to see. So that's the reason why this one is hidden. So let's see what's happening here. So we need to read a little bit more, but what we're doing here is that we do a near text search on travel jacket. We still want to have the title, description, and the link. We're going to still iterate over it. We're going to take the link, in this case, the image, right? So the image URL is the link. And what we're doing is that we basically give it a instruction. So write a short Facebook ad about this product photo. We generate it and we store that information back into the database. And as you've seen in the beginning, if we store something in the database, it gets a vector embedding. So same will happen here. So we're going to go over these results. It's going to generate the Facebook ads in this case, and store that back in the database. So here you see we got this photo from the database. Let's look at it. So here you go. This is the photo, right? And then we say, stay warm and stylish with this winter, blah, 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 et cetera, et cetera. We've stored that now back in the database, again, with a vector embedding. So we made the whole cycle, right? This was the feedback loop. And we did that for all these products that are basically matching the results. So now, if we retrieve that information, we see that we now all of a sudden not only have a description, but we also have that generated description in the database with a vector embedding. So now we can search over it. So we can just ask the database, just keep generating whatever we want based on our data. So what might be a use case for that? Why might we want to do that? Well, because this is an e-commerce use case, let's think about personalization, right? So I'm going to create a new collection, and this collection is basically called personalized. I'm still going to use the same models that I was using before. I have a description, and I make two graph connections where I say a description of a product and a description of a persona. So I need two personas who are going to query my e-commerce data set. So what's a great way to generate two personas? Well, use the generative model to do that. So we ask the generative model, create a fictional buyer persona named persona, Alice and Bob, and we store them in the database, again, with a vector embedding. So here we go. We're going to get two personas that are being generated, and we're going to output them. We're going to print the results. So here you see Alice, age 35, occupation, marketing manager, and so on and so forth. And we have Bob, information about Bob, and that's also now stored in the database. So if I now get them out, very similar as we see with the products. So the database gives them a unique identifier. The description is stored in there, and these personas now have a vector embedding attached to them. So as you know, we have like 100 products in the database, right? And two personas now. So one of the things that we can do, and I need to copy here the product that I just picked. So what we're now going to do is basically we're going to tell the database from all the products that we, or this specific product that we have, generate personalized, unique product descriptions based on the personas and based on the products that are in the database, and store them with these graph connections. So what you now see that's happening, if we store that information, it says here, it has the Google laptop bag, and as a busy CFO, Bob, you understand the importance of a reliable companion, et cetera, et cetera, et cetera. So what we're doing is that now the database is taking care of the personalization based on the personas we stored in the database and based on the products we stored in the database. And it just schedules those and does that for you. You don't have to do that yourself anymore. So we look now at use cases where people, for example, say, hey, we have a Weaviate with like a couple of hundred of thousands of products. We have thousands of customers. We know what they bought because it's in our database. We're now going to just generate personalized descriptions of these products because we know what these people are interested in. And they're not only doing that for text, but they're also doing that for images. So if somebody searches for socks, but they always buy yoga outfits or something like that, you can just now generate an image of these socks laying on a yoga mat. It's just the database doing that for you, just based on the fact, as you've seen here, that you just go to a situation where you give the instruction to the database, right? And last but not least, the whole thing that's nowadays very hip in vector search space are these knowledge graphs. That's literally what we're building here. So we take the collection personalized from the database. We're just going to get 2 out because we have Alice and Bob. And we're going to say, show me the vector embeddings. Show me the product that they're related to, the title, the persona, the name of the persona, and just iterate over them and print them out. So now if we all pick this together, we just create a database. You see that just happens in a couple of milliseconds. We just get a little knowledge graph here. So we have a description uniquely generated for that product, for the Google Laptop Backpack. So introducing the Google Laptop Backpack, the perfect partner for Alice. It's generated for Alice. And the unique vector embedding generated to search through that vector space for this uniquely generated object is what you see here. All done automatically by the database. Here, same product, the Google Laptop Backpack, your trusted ally for professional successes as a busy CFO, Bob, blah, blah, blah. This is the product for the persona Bob, and you see a unique embedding for Bob. So this is where we believe that everything is going, right? So we're just basically literally weaving, that's where the name Weaviate comes from, the models, the vectorization models, the generative models, and the database together. Just in a couple of lines of code, you can create completely personalized data sets, or whatever data set you have and whatever instruction you have. Just as you've seen here in a couple lines of code. So this is what we believe is the new thing. If you go to our website, you can read all about these generative feedback loops. And again, going to what I previously said, it starts with vector search. On top of that, we have hybrid search. Out of that came RAG, where this vector database plays such an important role. And then the third thing that came out of that are these generative feedback loops, where we're basically going to tell the model, we're going to give you an instruction, you're going to get access to the database, fix it for me, right? So thank you for listening. That was my talk, and I hope you enjoyed it.
As with new features, I'm sure there are lots of questions. Yeah.
So for the connections you mentioned, are those planned to be pre-computed, or the connections between the persons and the items, let's say, are they planned to be pre-computed or computed on the fly?
They're pre-computed. So in this specific case, they're pre-computed. So basically when we create them, and you can actually see that here. So here we set a reference in the database. So the off product and the off persona is set on adding, in this case, that information to the database.
But in real life use cases, like the number of products and users blow up, so wouldn't the combination be a bottleneck?
Not per se. So it's like, if it purely look at the graph connections, many to many is tricky. But one of the things that you can also do is that you can do that in vector space too. So you can say, okay, just group them together and show them. So this is a traditional graph connection, but you can also group them together in vector space. Depends a little bit on the use case that you have. But for these kind of things, this works great.
Right. Like the thing I'm trying to compare this to is, instead of pre-computing, on the fly, you give the job seeker, the profile of the user and the product description, and ask an LLM, tell me how they're related, or how would you sell this product?
Yeah, so you can do that. So it again depends a little bit on the use case. So we see some people building with this where they have all the information up front. So they just compute it in a scheduler. And sometimes people say we do not have this information up front. So we now need to, the user needs to take an action to have enough information. And then you do it on the fly. And the bottleneck, of course, is the inference over the model. But as you can see here, just a demo over Zoom, that's already pretty fast. And if you pre-compute it, then you do it in 20 or 30 milliseconds. Then it's really fast.